our first video, we studied about the general introduction of group 15. We studied about the elements of group 15. We studied about the physical nature of group 15. We studied about the oxidation state as well as anomalous behavior of nitrogen in our first video. In this video, we are going to discuss something about the chemical properties of group 15. Group 15 consists of nitrogen, phosphorus, arsenic, antimony and bismuth. All these elements react with hydrogen. First, we are going to study about the reaction with hydrogen. So, all these elements react with hydrogen, form hydride of the type EH3. The general formula of the hydride formed by the elements of group 15 is EH3. For example, nitrogen react with hydrogen form NH3. Phosphorus form PH3, arsenic form AsH3, antimony form SbH3 and bismuth form BiH3. NH3 means ammonia, PH3 means phosphine, arsine, stiphene and bismuthine. These are the hydride of group 15. If you discuss about the bond dissociation enthalpy of this hydride, when we move from top to bottom, when we move from ammonia to bismuthine, the bond dissociation enthalpy decreases. Bond dissociation enthalpy decreases. That means the stability of these hydrides decreases on moving down the group. On moving down the group, the stability of these hydrides decreases. The next thing, the boiling point and melting point, when we move from top to bottom, decreases. When we move from top to bottom, the boiling point as well as melting point decreases. But in the case of ammonia and phosphine, NH3 and PH3, PH3 possesses lower melting point and boiling point than that of ammonia. Why phosphine possesses lower melting point than that of ammonia? Because ammonia molecules are associated by hydrogen bonding. That hydrogen bond is absent in phosphine. Therefore, phosphine possesses lower melting point than that of ammonia. When these elements dissociated, they are liberating hydrogen. So this hydrogen acts with the nearby substance. That means the hydrides of group 15 act as a reducing nature. The reducing nature also increases on moving from top to bottom. On moving from top to bottom, the reducing character increases because the bismuthine acts as a more reducing or having more reducing character than that of ammonia. Basic nature of this hydride, that is the basicity of these hydrides, decreases on moving down the group. That is NH3 having more basicity than that of PH3, which having more basicity than that of AsH3, which having more basicity than that of SpH3 and that of BiH3. So the basicity of this hydride follows this order. The order of basicity is on moving from top to bottom, it decreases. Reaction with oxygen. These oxides in higher oxidation state are acidic in nature. The oxides in higher oxidation state are acidic in nature. Also, when we move from top to bottom, the acidic character decreases. That means the oxides of nitrogen and phosphorus are purely acidic in nature, whereas the oxide of bismuth is basic in nature. But the oxide of arsenic and antimony are amphoteric in nature. Reaction with halogen. All these elements of group 15 react with halogen forming halide of the type EX3 and EX5. So all these elements react with the halogen forming two types of halide. One is trihalide, another one is pentahalide. Since nitrogen does not have d orbital, it cannot form pentahalide. Among the elements of group 15, nitrogen form no pentahalide due to the absence of d orbital. The pentahalides are more covalent than that of trihalides, because the pentahalide, the element in +5 oxidation state, more positive oxidation state, induce more polarization of the bond. Therefore, the pentahalides are more covalent than that of trihalides. If you talk about trihalide, all the trihalide except the trihalides of nitrogen are stable. All the elements are forming trihalide, but except the trihalide of nitrogen, all the other trihalides are more stable. In the case of nitrogen, NF3 is the only non-stable hydride. Reaction with metals. All these elements react with the metal forming binary compound. In this binary compound of these elements with metal, the elements are exhibiting -3 oxidation state. So all these elements of group 15 react with the metal forming binary compound. In this binary compound, the elements are exhibiting -3 oxidation state. For example, Ca3N2 calcium nitride, Ca3P2 calcium phosphide, Na3AS2 sodium arsenide, Zn3Sb zinc antimonide, Zn3Sp2 zinc antimonide, Mg3Bi2 magnesium bismuthide. So all these elements react with metal forming binary compound. In this binary compound, the elements are in -3 oxidation state. That's all about the chemical reactivity of group 15. Dinitrogen. So, dinitrogen is prepared commercially by liquefaction and fractional distillation of air. When air is subjected to liquefaction followed by fractional distillation, we are producing dinitrogen commercially. But in the laboratory, it is prepared by treating aqueous ammonium chloride with sodium nitrite. When aqueous ammonium chloride is treated with sodium nitrite, we are getting nitrogen in the laboratory. But in this reaction, nitric oxide and nitric acid, NO and HNO3 are formed as impurities. These impurities are removed by passing the resultant gas through sulfuric acid, which contain potassium dichromate. When we are passing the resultant gas through the mixture of sulfuric acid and potassium dichromate, the impurities such as nitric oxide and nitric acid are removed from the gas. Nitrogen can also be prepared by the thermal decomposition of ammonium dichromate. Ammonium dichromate are subjected to thermal decomposition. Thermal decomposition means on heating. Ammonium dichromate on heating we are getting nitrogen. So nitrogen can also be prepared by the thermal decomposition of ammonium dichromate. What about the equation? Ammonium dichromate NH4 twice Cr2O7 on heating gives N2 plus 4H2O plus Cr2O3. But the very pure form of nitrogen is prepared by the thermal decomposition of barium acid. Either barium acid or sodium acid on heating, we are getting very pure nitrogen. That's all about the preparation of nitrogen. What about the preparation of nitrogen? Commercially, it is prepared by subjecting the atmospheric air to liquefaction as well as fractional distillation. Also in the laboratory, it is prepared by treating aqueous ammonium chloride with sodium nitrite. It is also prepared by the thermal decomposition of ammonium dichromate as well as thermal decomposition of either barium or sodium acid. Properties of dinitrogen. Dinitrogen is a colorless, odorless, tasteless and non-toxic gas. Colorless, odorless, tasteless and non-toxic gas. It having two stable isotopes, that is N14 as well as N15. Dinitrogen react with the metals forming ionic hydride, whereas it reacts with non-metal forming covalent hydrides. But this reaction takes place at very high temperature. We already studied dinitrogen is inert at room temperature. Why it is inert at room temperature? Because of the very high bond dissociation enthalpy of N triple bond N. So all this reaction takes place at elevated temperature. At very high temperature, nitrogen reacts with oxygen form nitric oxide. So nitrogen reacts with oxygen forming nitric oxide. Uses of dinitrogen. So dinitrogen is used where the inert atmosphere is needed. The first use is nitrogen is used where the inert atmosphere is needed. In industries, it is used mainly for the manufacturing of ammonia. In industries, it is mainly used for the manufacturing of ammonia. Liquid nitrogen is used as a refrigerant for preserving biological specimen. Also used in cryosurgery. Cryosurgery means the surgery which takes place at extremely cold condition. That's all about dinitrogen. So in this video we studied about the chemical properties of group 15 as well as dinitrogen.